Welcome! I'm very excited to introduce you to a new component from the WXPack. You will now be able to display and edit math formulae very easily. The best thing, you can enter your math in a variety of languages. I've decided instead of talking about the features, I'm just going to show you the 1, 2, 3 steps that you need to take in order to integrate a fully blown math editor into your application. In this case, I picked a VCL application, so we have the main form, the object inspector, and the main form open. So I select from the TMS FNC WXPack category the new WX math editor. I drop it on the form. I set alignment to aligned, so the whole form is being used. And an example for formula just appears. With this, we're done. We can run the application and our math editing and display is ready. I increased the form size a little bit because we cannot only enter form like this, like times 2x minus 3y. No, we have actually keyboards that allow us to enter stuff much quicker. For example, 3y times, and then I can add a square root, 2x times, and we're underneath the square root still, 2x times y times that. This is an awesome user experience. And even better, there's multiple keyboards that you can use. For example, here is a keyboard for all the Greek letters. Here's another one for different functions like sine, cosine, and modulo, or even sigma for sums or integrals. Everything is there that the heart desires. Exists math, or you have different number ranges like real numbers, imaginary numbers. All the different symbols are there, and also underlines, overlines, vectors. Everything you might need in a math formula is here accessible through keyboards. But that's not all. You can go into the LaTeX command mode. Let me explain what LaTeX is. LaTeX is a typesetting system that is very similar to HTML, Markdown, but way more powerful and customizable. It is almost like a programming language to create books and other documents. You can create anything with LaTeX. I can simply use backspace sum, and the lower index, for example, is x equal, or I is usually used. I is from 0 to, and then I have to specify the range. For example, I can say 20 again, and then I can specify the formula, like 2i, for example, or 2 times I. And if I press enter, everything gets converted to a formula. And this is not the only language that is supported. And to learn more about this, I advise you at this stage to go into the demo application that is bundled with the product. The demo application allows you to test, edit a formula, use all the different keyboards. We have different keyboard themes: material theme, Apple theme, and device specific. You can select the different languages that are available. I already mentioned LaTeX. You can also use ASCII math, spoken text, MathML, spoken and spoken SSML, and specifically LaTeX expanded syntax. So we have looked at all the different things that the user or the end user sees. What can you do as a developer, for example, to take a snapshot and save this formula as a bitmap or any other graphics type? And as always, TMS makes it very easy. First of all, you have the object inspector with a plethora of different properties. The math property, for example, gives you access to the formula in a specific language, and the specific language can be specified using math format right here. I already introduced you to those, showing the demo user interface. And then here you also have access to all the different virtual keyboards, virtual keyboard themes, and so on. Also, I showed it already, the alignment and anchors are of course supported. Also keep in mind the events. Here you have on get math, that is being triggered when you want to read the math from the formula that is being shown right now, and on capture screenshot. You need these events because if you ask for something on the web, it takes a little while for it to be processed. Everything is asynchronous, and this concept transfers to the WX controls, meaning you ask for something and an event yields the result for you. And if we look, for example, at the implementation of getting the screenshot, you call capture screenshot, and that's it. And capture screenshot triggers the capture screenshot event as soon as it's ready. So here you can access the parameter, which is an FNC bitmap, and you can simply call save to file to create a PNG file of the formula being shown. Downloading the math that is used in the formula works the same way. Let's look at download file. We call get math for the language that has been selected in the combo box. And then at some point in the future, the event is called. Selecting the math editor again on get math. And on get math then allows you to store the information in a text file. Here, math.txt. The math is returned as a string with a correspondent format that gives additional information what format it is in. There's even more than meets the eye, because if you, for example, call the TMS FNCWX math editor instance in code completion, there are a lot of methods available, like delete backwards. So the whole editor can be controlled using methods. If you want to know which methods are available, in addition to the developer documentation from TMS, a link is given to the documentation of the original underlying JavaScript web control called MathLive. And the listing of all the commands gives you all the different editing commands, like I just mentioned, delete backward, and of course the edit menu for undo, redo, cut to clipboard, copy to clipboard. Everything is supported. Very well chosen method names. You don't really need it if you are happy with entering a formula interactively. And after your user enters the formula, you have basically two options. Either you take a snapshot or you download the file. And of course, downloading the file is not a one-way street. You can assign the value that you store in this file or string or database to the editor, and then the editor will show the formula again, of course. So this is a two-way street. This has only been a brief introduction to a very detailed control for math formula in your Delphi applications. Again, it is available for the FNC framework, which can be used with the VCL and FireMonkey, opening up the world of cross-platform development. Read more at fnc.tmssoftware.com.